What if we start mining asteroids? The world's resources are running out. In the near future, it's possible that supplies of cobalt and nickel could be completely exhausted here on Earth. Not only will that grind our technological progress to a halt, but it could stop us from exploring space, as there just won't be the materials to build spacecraft. Could mining asteroids be the solution we've been looking for? By the end of the 2020s, an outer space gold rush could be well underway. Fleets of space vehicles, some with humans on board and others operated remotely or by artificial intelligence, could be leaving Earth in search of metals, minerals, and more. In this video, we're going to take a closer look into asteroids, whether we should be mining them, and find out what resources are up for grabs. Keep your eyes and ears open for the 3 asteroids we have named in this video. The first 3 people to let us know the correct answer in the comments below will get a shout out on our next video, so keep watching. Trillionaires will be the ones who make their fortune in asteroid mining. It's only recently that this has been viewed as a serious possibility, which has led to the creation of asteroid mining firms and the passage of legislation that recognizes the right of companies to prospect, claim, and extract space-based resources. The idea of mining an asteroid probably sounds like something right out of a science fiction movie, but as it turns out, it's something that we'll need to become really good at as we aim to extend our footprint into the spans of deep space for exploration. Asteroids are very rich in rare elements, even those that are impossible to form here on Earth. On the other hand, getting mining equipment to asteroids, collecting valuable materials, and then shipping them back to Earth for the sake of commercial profit is a challenge unlike anything ever seen before. Asteroids could potentially serve as pit stops between long-distance trips, providing important resources for space missions such as fuel, manufacturing materials, and much more. But with so many people saying we're just right around the corner from being able to mine asteroids, how far into the future is it really? Probably more distant than you think. While the idea of mining a ton of precious metals on asteroids for profit sounds nice, space agencies will be focusing primarily on learning how to extract water from asteroids, as this is a vital component of both rocket fuels and life support systems. Developing the technologies to make this happen and then finding the proper asteroids to extract the materials we will need are just some of the challenges we face to make it possible. So what are asteroids? Roughly 4.6 billion years ago, our Sun formed from a nebula of gas and dust that experienced gravitational collapse at the center. According to one common model, having consumed most of the material from the solar nebula, the rest of the gas and dust formed into a large flat disk around the Sun's equator, a circumsolar accretion disk. Over the next eons, this disk gradually condensed in place to form the planets. Asteroids, according to our current astronomical models, are the material left over from the formation of the solar system. In this respect, asteroids and planets like Earth formed from the same starting materials. On Earth, gravity pulled most of the heavier elements like iron and nickel into the core during the Archean eon, roughly 3.5 billion years ago. This process left the crust depleted of much of its heavy metals and heavier elements. One model hypothesizes that during the heavy bombardment period around 4.1 to 3.8 billion years ago, a disproportionately high amount of asteroids collided with the terrestrial planets, Mercury, Venus, Earth, and Mars. These impacts would have then re-infused the depleted crust with metals like iron, nickel, gold, cobalt, and platinum, to name just a few. But which asteroids are suitable mining targets? More than 750,000 asteroids have been identified to date. The vast majority can be ruled out instantly, as they are found in the main asteroid belt orbiting between Mars and Jupiter, too far away to be considered as potential mining targets. Instead, we should focus on the asteroids near Earth, of the right size, and have a high enough concentration of valuable and widely used metal, which narrows the search to around 17,000 targets. According to Professor Martin Elvis, an astrophysicist at Harvard University, an asteroid worth mining needs to have a market value of $1 billion. Let's look at just 3 types of asteroids, see what resources they have and how much are up for grabs. These asteroids all have different resources and different challenges to mine them. First up is 16 Psyche, a relatively large asteroid at 140 miles wide. But it is unique in the asteroid belt as it's mostly metal, around 60%. This has made scientists wonder if it's the leftover core of a long-dead planet. But because of its high metal content, it's a potential prime target for asteroid mining. Although there have been numerous articles claiming it's worth $700 quintillion and is made of gold, there's no hard evidence to back this up. In fact, 16 Psyche is mostly made up of iron, cobalt, nickel, and maybe a few gold deposits and is worth $27.67 billion. It also orbits close to the inside of the asteroid belt at 2.9 astronomical units, so it's relatively easy to reach, which means that mining it should be cheaper than further afield bodies. So while 16 Psyche isn't the giant ball of gold many thought it was, it's still a very valuable chunk of space rock. Next, let's look at Ryugu, an asteroid we have actually visited with the space probe Hayabusa 2. This is potentially the most efficient asteroid we could mine and is top of the list as far as a potential candidate. Ryugu is designated as a near-Earth asteroid and potentially hazardous as it could impact the Earth. At 1 kilometer in diameter, it's a lot smaller than 16 Psyche, but it's still worth a staggering $80 billion. Like 16 Psyche, it's also made of nickel, cobalt, and iron, but in larger concentrations. However, as this asteroid is so much closer to Earth at 1.19 astronomical units, it makes it really efficient to mine. Lastly, let's look at a monster of an asteroid, Anteros. This asteroid is small like Ryugu at 2 kilometers in diameter. However, unlike the other two, this asteroid is rich in aluminium, magnesium silicate, and iron silicate. While these silicates are common on Earth, the vast amount of aluminium means that this asteroid is worth $5.5 trillion, which makes it worth around 1% of the global economy. It also seems to have a really advantageous orbit because it's coming very close to Earth at 1.06 astronomical units. But it has a slightly elliptical orbit path and its furthest point is 1.8 astronomical units. This means that although this asteroid is worth far more than the others, its eccentric orbit makes it rather difficult to mine. But why do we need to mine asteroids? Surely it would be far too expensive to even try. Why not simply continue to rely on Earth for sources of precious metals and resources and simply learn to use them better? To put it simply, we're running out of resources. Of course, learning to use our resources better and more sustainably is always the best option. And while it's certainly true that Earth-based mining is far cheaper than going to space would be, that may not be the case indefinitely. Aside from the fact that off-world minerals and ices would be of considerable value to Earth's economy, there's also the way that growing consumption is leading our reserves to become slowly exhausted. In fact, according to some estimates, it's possible that our planet will run out of key elements that are needed for modern industry and food production within the next 50 to 60 years. This alone is a pretty good incentive to try and tap the seemingly inexhaustible supply of elements located off-world. Plus, there are a lot of benefits to expanding humanity's resource base beyond Earth. Here on Earth, mining takes a considerable toll on the natural environment. In fact, depending on the methods used, it can result in erosion, sinkholes, habitat destruction, and the destruction of native animal and plant life. There's also the dangers of toxic runoff and the contamination of soil, groundwater, and surface water, which is a danger to humans as well as to wildlife and the natural environment. As for smelting, machining, and manufacturing, the environmental damage that results is well documented. Combined with power generation, these industrial processes are some of the leading contributors to air and water pollution. By shifting these burdens off-world, humanity could dramatically reduce the impact such mining has on the natural environment. If we could overcome the logistics of mining asteroids, how would we go about it? There are several techniques that are possible to use in the process of mining asteroids. Surface mining, where minerals could be removed by a spacecraft using scoops, nets, and augers. Shaft mining is another possibility where spacecraft equipped with drills bore into asteroids to extract the materials within. Another idea is to capture asteroids in nets and then tow them closer to Earth. Once in lunar or low Earth orbit, they could be mined by smaller extractor spacecraft, which would then transport the resources to orbiting platforms. Steam propulsion is another method that has been proposed for asteroid mining. In this case, robotic spacecraft would harvest the oxygen in water ice to manufacture propellant, giving them a degree of self-sufficiency and the theoretical ability to mine indefinitely. Now for the question, should we mine asteroids? Well, the technology that will allow us to is only just emerging, and even then it still isn't a highly profitable business, even if the asteroids are worth trillions. But in the near future, we're going to run out of resources on Earth, and we may even be colonizing other planets. When this new era of human expansion comes into play, then we believe we should mine asteroids as it will give us the resources we need to explore the solar system and become an interplanetary species without draining the already diminishing resources of our home planet, Earth. What do you think about mining asteroids? Is it a good thing? Did you manage to find the answer to our question? Be one of the first to let us know in the comments below, and we promise to give you that shout out on our next video. Please like this video if you've enjoyed it. If you want to see more videos like this one, then subscribe to Brain Impact for more. Thanks for watching.